Okay, so how are cryptocurrencies correlated? Let's find out using Python and the Binance API. To better follow along, I recommend to check out some videos, which I will link in the video description. Here are the steps we will go through. As always, I will additionally leave timestamps. So first of all, we are getting all relevant symbols traded on the Binance platform, then getting historical prices for those over the last year. Then we are calculating daily log returns, create a correlation matrix out of that, and visualize and analyze that. That said, I hope you have fun watching or at least can extract value out of this video. Alright, so let's get started. As you see, we need some libraries, pandas for data handling, the Binance client to get data from Binance, such as all relevant symbols and the historical prices, and we NumPy to calculate log returns. Here we are instantiating the client, and first of all, we want to get all symbols traded on the Binance platform. Therefore, we can make use of the get exchange info function, and this is providing us a dictionary containing a lot of, in our case, unnecessary information, but also all symbols traded on Binance. So you see that here. So we are filtering this dictionary for only the symbols, and we can do that using a list comprehension. So we are storing that in a variable symbols and use x symbol for x in info symbols. And with that, we are getting all symbols here, right? Now we only want those symbols in relation to the US dollar theta. So we want to exclude pairs here. So we can again use a list comprehension to achieve that. And we are just calling that relevant and use symbol for symbol in symbols if this symbol ends with US dollar theta. All right, and with that we are ending up with the coins in relation to the US dollar, BTC, ETH, BNB, and so on. All right, and now we need a function which is providing us historical prices for the last year on the 1 day time frame for a given symbol. And we can use a function which I was using in previous videos. So I just copy paste the function from my other screen here. Anyhow, let's quickly go through that together once again. So this function get daily data, what exactly is this doing? So first of all, it's pulling K-line or open, high, low, close data for a given symbol on the 1 day time frame, 1 year back. All right. And I added an if condition here, which is just checking if we are getting any data at all. So this is important because we are looping through all symbols later, and I just want to avoid the loop getting stopped when we have empty data frames here. This is just screening for all relevant columns. So the last column here is containing the close price. It is renaming the columns and then is setting the index to a datetime column, and Binance is using Unix timestamps, so I'm just translating that to human readable timestamps, and I'm also converting the string values to floating values so we can calculate with them. So let me quickly just show you how this is working. Let's call this function on the Bitcoin USDT. And you will see we are getting open, high, low, close data for the Bitcoin 1 year back here, right? Okay, and now we are simply just looping through our relevant list. So relevant list, once again, is containing all symbols, and we're just calling this function. And we are storing that somewhere. So we are creating an empty list for that. And now we are looping for coin in relevant. And then we are just appending all these data frames to this list here, right? So we are calling the function get daily data on every coin and append that. So this will take roughly 3 minutes. So I will cut it here. Alright, so once the loop has finished, we want to take a look at the created list. And as you see, we are getting a data frame containing prices for all those symbols in our relevant list here, right? We know that, for instance, this data frame belongs to Bitcoin because Bitcoin is the first element in the relevant list. But Python does not know yet, right? So we have to map those data frames to the coin. And we can use a zip function to achieve that because we know the first symbol in the relevant list belongs to the first data frame in the DFs list. And we can zip the relevant list and the DFs list and apply a dictionary to that. And with that, we are getting a mapping system containing that this is the data frame for Bitcoin, this is the data frame for another coin, and so on. So we are zipping the relevant list and the data frames together and then wrap that into a dictionary. And with that, we are getting this. So now we know, okay, this is the data frame for Bitcoin. This is the data frame for ETH. This is the data frame for BNB, and so on, right? And with this mapping, we can concatenate all those data frames in one data frame. And this is our primary goal, right? So we don't want to have separate data frames, but we want to have it all in one data frame so that we can calculate our correlations. So we can use pd-concat on this, and we want to concatenate that on axis 1, right? And if we are doing that and setting the parentheses properly and focus on setting the parentheses really properly, then we are getting a data frame like this. And this is our goal, right? So we want to have a data frame for Bitcoin here, we want to have a data frame for ETH, we want to have a data frame for BNB, and so on, right? So we can store that, let's say we are calling that merged data frame, right? And as we calculate our returns on the close column, we only need the close column, right? So the other columns are obsolete for now or for this analysis. So let's first of all store that in the merge data frame. And now let's just create a data frame for the close prices. So I'm just calling that closest data frame. And this is quite tricky because this merge data frame has a multi-index as columns, right? We have Bitcoin here and also the open, high, low, close columns. So we need to get the level values on the second level here and filter for the close column. So we can do that by using merge df log, get our rows, and then get only the level 1 values containing close, right? So we can do that by merge df columns, get level values, and then the second value, which is 1, because first level would be 0, and then we're just screening for if that isn't close. Okay, and with that, we are getting what we wanted to get here, right? And as we just want to have this level now, only so we don't need this information because these are all close prices, right? So we just want to get rid of this level here. And we can do that by just using closest df columns and then drop level 1. Because this is level 1, we don't need that anymore. Okay? Yeah, wrong syntax here. Okay, so with that, we are getting what we wanted to get, right? Close prices for all our coins on the daily base over the last 1 year. And now we can start calculating the log returns, right? So we can just call that log return data frame, and we are using the log function from NumPy, apply that to the closest data frame and pass the PCT change function +1. I have videos on why I'm doing that on my channel, which I will link in the video description. And with that, we are getting a log return data frame, as you see on daily returns, right? And out of that, we can create a correlation matrix by simply calling the corr function from pandas. And as you see, we are getting a big time correlation frame here. So just as a recap, this is a 1 because this is the correlation between the asset with itself, right? So Bitcoin, Bitcoin, ETH, ETH, BNB, BNB, NEO, NEO, and so on. And this is the correlation between Bitcoin and ETH, which is the exact same value as here, as we have Bitcoin ETH here. All right. So let's visualize that as I did in my last community post. So we need Seaborn for that. So let's actually import that. Import Seaborn as SNS. It's a pretty nice visualization library. And now we can just use the Heatmap function and apply that on our log return correlation data frame. Okay. And with that, we are getting a very, very small chart here, not containing all currencies. So we have to increase the plot size here. So I'm quickly showing you how we can do that. But you can play with different plot sizes on your own here. So figure size. And I think in the community post I took 50 and 30 here. Right, so we can set that and plot that again. And as you see here, we are getting this big time correlation heat map, right? So you can double click on that, getting more insights on that, right? By the way, someone was commenting this looks like a Scottish kilt, so I don't know if that's positive or negative, but anyhow, if you're not comfortable with this color map, you can change that to, for example, Viridis. It's a pretty popular one, but there are other options as well. Furthermore, you could be interested in not all cryptocurrencies, but maybe a set of cryptocurrencies, right? So you can just filter the log return data frame as you would filter any other data frame. But let me quickly cover that for you here. So you could just take log return data frame and filter for, let's just take these examples, Bitcoin, ETH, ADA, Doge, and SHIB, and create a correlation matrix out of that. And with that, you are getting the coins you're interested in. And again, you could wrap that into a heat map again. And you're getting a correlation heat map like that. Okay. Now, next interesting question could be, how is a particular given cryptocurrency correlated to the other cryptocurrencies, right? Therefore, we are just creating a variable here, corr_df, and just create the correlation matrix and store that in a variable. And now we can index this for, let's say, the Bitcoin, and we're getting all the correlations to the Bitcoin. And now we could filter that for the largest correlations here. So for example, top 20, and we are getting these correlations. So this is something I would have expected: high correlation to ETH, high correlation to Litecoin. This one I didn't know. People, maybe you know it, but it has a very high correlation to Bitcoin, and yeah, some other not that surprising stuff here. The other side would be interesting as well. So what are the negative correlations to the Bitcoin? We can use n smallest here. Well, this is the contra coin BTC down, right? This the shorting. This of course has a nearly perfect negative relationship. But other than those down tokens, yeah, those are only the down tokens. Let's see. So what could be interesting here? So for example, this one, a pretty hyped token some weeks ago, Cocos, has a very low correlation to Bitcoin. Here we have some negative correlations as well, but these are only the down coins, right? So maybe you want to filter them out as well. Okay, right. So is there anything else? What could be interesting here? Yeah, of course you have some data here which you could filter out, right? So to the currency pairs here, for example, GBP. So there's a lot of improvement potential here as always. Last but not least, let's find the highest correlated cryptocurrencies. In order to get meaningful results, let's exclude the leveraged tokens. So I'm using a similar approach as I was using in one of my previous videos. I'm just creating a list containing the words indicating that this is a leveraged token. So a leveraged token, for example, is BTC up USDC, BTC down USDT, and so on. And I'm simply filtering my relevant list for those cryptocurrencies containing one of those words. And to achieve that, I'm creating another list here and loop symbol for symbol in relevant if all excludes not in symbol for excludes in exclude. Alright, and with that I'm just getting those symbols not containing an up, down, bear or bull and getting rid of the leveraged tokens. So I could have done that in the very beginning before requesting the data, but maybe you need the leveraged token in your analysis as well. So yeah. Anyhow, let's filter the correlation data frame for only those non-leveraged tokens here. Right, and therefore we're using correlation df and filter for the non-leveraged tokens on the axis 1, and with that quickly showing you getting the columns filtered, but as this is a correlation matrix, I still got the rows containing the leveraged tokens, right? You see that here. So I have to again filter that on the 0 axis. Right, so if I'm doing that, as you see, I'm getting rid of the leveraged token. And yeah, we are storing that in a variable which I'm calling stacked, as this is stacked data. So containing rows and columns here, and I want to get unstacked data with that. I'll show you in some seconds how unstacked data is looking like in case you don't know. So we are assigning that to stacked. And this is our stacked data. And our unstacked data is looking like this. So you have the cryptocurrency and then all the related or all the other cryptocurrencies and their correlation coefficient. All right. And yeah, we can use that now to find our highest correlated cryptocurrencies. So we are just assigning that to unstacked. And now we can apply unstacked and check for the largest ones. And these are, yes, these will be the correlation coefficients of the cryptocurrency in relation to itself. So of course, these are just the same cryptocurrencies. So in order to get the, in quotation marks, real highest correlations, we can just filter out the perfect positive correlations here by simply taking a look at only those smaller than 1 here, right? And with that, we are getting the highest correlations out of the whole Binance universe. So is there any interesting here? Well, depends on what coins you're interested in, right? So I see Cake is very highly correlated to BNB, BCH highly correlated to LTC. Let's actually take a look at the even lower correlation. Yeah, these are interesting results. So we have the Ethereum highly correlated to the Bitcoin. I would have expected that. anything else what could be interesting? Yeah, of course, Litecoin, highly correlated to Bitcoin, and so on. So yeah, let's take a look at the other side. So other side, I mean the negative correlations. So of course you could also take a look at the correlations near zero. Could also be interesting, right? I'm just showing you some stuff I would found interesting to check out. So smallest correlations here we see, or negative, highest negative correlations, not smallest. We see here. Yeah, but for me, nothing interesting, maybe for you. Yeah, nothing I can comment on. But anyhow, I think you got the main point of this. Yeah, play around with that for yourself. Check out what you find interesting. And I think it's a good starting point to do your own analysis stuff. And yeah, I thank you very much for watching. Hope this was interesting for you. And I'm looking forward to seeing the upcoming videos. Bye bye.